Hi folks, this is Sunjiro and I welcome you to this video. Um, I wanted to share a project that I'm working on in Sonic Pi to create a generative music track, and I thought that it might be interesting or helpful to people, and I've been getting a lot of love on some of the streams and tutorials that I've been doing, so I wanted to give a quick run through of this particular track. As you can see, it's quite a massive project, and so I want to try to focus on some of the higher level concepts rather than diving too deep into the project. So, with this, I'll talk a little bit about integrations. I'll talk a bit about this idea of the phrase controller, which I see as the main like offering of this project, and a little bit about MIDI CCs, right? And so with that, we'll begin. I will play the track in the background as we move forward, and you know, uh, pause and start over as necessary for the piece. So this track is called Lupin Tulpa, and the name is kind of a play on both Jay Dilla and Cocteau Twins. And so what's happening here with this track is I have two sort of musical ideas. One that is inspired by Jay Dilla with some like heavy percussive pieces, using a drum kit in Ableton that is based on some of his work. And then on the other end, we have this sort of like Cocteau Twins, like spacey guitar sounds, more ambient sounding music. And so the reason why this title is important for the concept of this track is that what we have here with this project is a composition in which the not only are the specific instrument pieces being generated, the actual flow of the track itself is being generated. So typically, when somebody is composing music, you'll have different sections, right? You'll have your hook, your intro, your chorus, your bridge, and it'll go through piece by piece. And all in all, the track will be maybe, let's say, 4 minutes long, and then it's over, right? With generative music, we have um, an instead of these sections in which you can count on them going from beginning to end, you wouldn't necessarily want for the same sections to loop through back to back, right? To go from the intro type section where certain instruments are generating based off of specific inputs, and then go to the bridge and so on and so forth, infinitely looping, because in that case, um, the generation will become quite monotonous, right? Or you could end up with the same sort of patterns playing over and over again. On the other side, you could create something where it's being completely random. You give it all of these variables at the start, and it's just randomly selecting each of those variables every time it loops through. But when you do that, you get very little control over what people are hearing, and ultimately, um, it might not have the effect or the sound that you're looking for. Maybe you still want to have sections or musical ideas that play at different parts without necessarily crowding each other, like what I've described here. With the more Cocteau Twins inspired stuff, we have these guitars that you can hear in the background right now, whereas with the Dilla stuff, we have more percussive elements, and I don't necessarily want those to play at the same time, right? And so with this, I've created something that I've been calling a phrase controller. And so um, a phrase in this case is like a section, a musical section, like a hook or like an intro, or like a bridge, right? But instead of it having to come in a particular chronological order, instead it's assigned a number, or it's assigned to a variable phrase. And what is special about this particular track or this particular composition is that this phrase controller, instead of saying we have phrases -3 through 3, randomly select what phrase is going to be playing at any given time. Instead, the phrase through this phrase controller can only jump one in either direction. So if it's 0, the next phrase could be -1, 0, or 1. If the phrase is 2, the next phrase can only be 1, 2, or 3, right? And so that makes it so that the track is able to flow and move in a much more organic way than if it was done randomly, without being incredibly repetitive in the case that it was, going from beginning to end, beginning to end, beginning to end, over and over again. And I think that generally this idea of the phrase controller is quite helpful in the sense that just the fact that you can edit this phrase controller and have it behave in these different ways. I could hypothetically say I want it to cycle through from 0 to 3 and then start over at 0 again. I could make it so that it goes from 0 to 3 and then it comes back down to 1 0 1 2 3 2 1 0, looping like that. Or we can use it in the way that I've done right now, right? There's a lot of possibility here, but I think that the core concept of a phrase and a phrase controller is really helpful for creating generative music, and it's something that has definitely helped me in thinking about how I'm creating these different compositions. And so I'll get down into it, I'll break down that code in a second, but before that, I wanted to just kind of address the elephant in the room, right? Like, first off, just very visually, it's very obvious that I'm not using the typical Sonic Pi editor, and based off of what we're hearing, it's obvious that I'm not using the Sonic Pi synths, right? And so I think that this is something that has really changed the game for me in terms of how I create generative music with Sonic Pi, by being open to using outside programs. So here, what we're seeing is that I'm using Visual Studio Code for editing my code instead of the Sonic Pi editor. And the reason for that is when we look at the code, we can see just how much stuff there is, right? And like right now, these sections are all closed, which makes it a little bit easier for me to scroll through without getting kind of lost in the sauce. Whereas with Sonic Pi, I find that the editor it gets clogged very easily. It's very hard to find what I'm looking for, especially without that search function. And so using Visual Studio Code makes it way easier for me to organize my code and understand what's going on, to jump between different sections, and also, just not feel necessarily overwhelmed about all of this stuff that's going on. I found particularly when I'm playing live sets, when I'm live coding, I can get lost in the different sections, and sometimes that causes errors or it causes mistakes in what's going on. And so I find that this makes it a lot easier to find what I'm looking for. Additionally, I really love that with Visual Studio Code, with the output, I'm also able to search inside of the output, which makes it really easy to test and to figure out what's going on as you are making music, as things are playing through. And so I really recommend for anybody who is familiar with another code editor to check it out and see if there are potentially extensions that make it possible for you to use Sonic Pi with it. So with Visual Studio Code, what I did was I actually, at first, before coming into Visual Studio Code, I looked to see if there was some sort of extension, and I started by finding one on GitHub, downloaded it, installed it, downloaded all of the dependencies, all of these things, and it didn't work. Then I came in and I went into the extensions and I searched and was like, okay, this one has 2,000 downloads, whereas this one has 500 downloads. Let me download the one that has 2,000. But I found that that one also did not work. And so finally I came and I gave this one a shot by S00500. And this one works. And the main reason is that the other two are deprecated or they're not deprecated, you can still use them, but this one is built for Sonic Pi 4 and above, whereas the other ones don't work with Sonic Pi 4. And so, you know, depending on where you are in history or in the future when you watch this, um, I would recommend this one by S00500, built into Visual Studio Code's extension marketplace. But maybe that'll change by the time you're watching this. And then, of course, the other thing that's important to note here is that I'm using Ableton for the actual generations of the sounds. And so Sonic Pi, I love it, the logic of it. I love using it to generate, different notes and different patterns, and I love being able to experiment, with different code and like rhythms and this alternate logic to making music, right? But I'm not in love with the synths that are built into the program. And so I tend to almost always use Ableton for when I am generating music with Sonic Pi. And so you'll find that most often my code is comprised of lots of different like MIDI functions essentially. But beyond that, on top of using Ableton, I typically use, and in this track you can see that I only have it for one of the instruments here, but I tend to use this synth called Surge XT, which is an open source synth that is available on Mac, Windows, Linux, and it's open source and free, and it has tons and tons of patches, and I love experimenting with them. You can create your own. You have like the ability to, here, let me come back, do all sorts of customizations, like changing skins and all sorts of really cool stuff. The main reason why I use Surge XT is because it makes it easy to troubleshoot if you're working with somebody who is using a different computer, like a different operating system, or using a different DAW. Surge XT makes it so that you can all have the same patches and the same sounds to make sure that stuff is working properly. I do a lot of teleperformance and teleproduction work where I'm making music with people who are in different locations, and so Surge XT really makes it possible to do that. And finally, I have this dream of creating like a generative album where instead of like having tracks that are 3, 4, 10 minutes long and then they end, it's like a program where you load it up and it plays continuously. And so I think that with that, I would like to kind of package this program with a Sonic Pi server, kind of like what I'm running with Visual Studio Code, and then Surge XT, which is because it's open source and you can kind of package it in there to make sure that the sounds are the same and you don't have to like download some other DAW in order for it to work. And so with that out of the way, these different integrations that I'm using, let's jump into the code itself. So there's, like I said, this code is really quite complex, right? So I don't want to get too deep into each of the sections. I've tried that and it ends up being like over an hour. If you do want to see that video, let me know and I can clean it up and release it. But just to kind of go over this like very broad strokes before getting into the phrase controller. Up top, I always start with the same stuff. So first, I set my BPM, and then I create a live loop for a tick. And so I use this live loop as a way to sync all of the later live loops so that if I'm doing like a live performance, when I run the code, it waits until the tick is starting so that everything is still in sync. With this one, I'm not really playing it live. It's more of like a generative piece, so I have the tick set to 1. But if you're doing like a live performance, I'd recommend bumping it up to something like 4, so that it's like a full bar passes before the next loop starts. Then after I have my basic things that I always include in my code, I have these different instrument definitions. And so you can see here we have 1, 2, 3 instruments, and then we have a number of drum patterns, drum 1 through 6. And with these, you can see that with the bass and the guitar, we have these other variables that are added here into the definition. So jumping into here really quickly, what's basically happening here is this is defining a function. And so when I call this function, I am able to give it another variable that then actually inputs that variable into when the function is being called. So I can, for example, with the phrase controller, this is really helpful because what I could do is say, when the phrase is 0, I want for the bass note to be sustained for 2. But if the phrase is 1, I want for the notes to be longer and more stretched out, so I'm going to give it a sustain of 4, right? And then that is passed back into the function when it's being called. And so that's a very, very helpful thing for creating generative music. Yes, so we have all of these definitions here. Another really interesting or cool approach that I learned from a really cool person on the Sonic Pi forums, Pashultz. They really helped me out throughout this code. I really got to give them a shout out for reading through the work that I was creating and giving me different suggestions. One of the things that they suggested that was really helpful, it's something that I've seen quite a few places, but they really broke it down and explained it in a helpful way, and I'll put the link to the thread in the description, was this sort of ring syntax, if you will, where essentially what I'm doing here is creating 2 rings, and one ring has the specific notes that will play, and the next ring will have the duration of the notes. And then after that, we have this function that plays the number of times as there are number of notes. So here we have 3 times. You do this, and then it ticks through and looks inside of this array or inside of this ring to figure out what note we're actually playing here. So this note is basically saying if it's on the first one, then it should be on note 1. And then it's using the same value here to then jump to look it's looking at the duration. And so if it's the first note, it'll also be the first duration immediately after, so it's sleeping that first duration. And then it ticks, so then the next time it plays, because it's doing it 3 times, the next time it plays, it'll say, okay, let's go to the second one, the second note, and also the second ring. So this is really helpful if you, if rather than doing something where the notes are being chosen randomly or generatively, programmatically, if you will, and the durations are being chosen programmatically, but instead you have it specifically composed, kind of like I do with the drums, the pattern, then this is a really helpful syntax or structure that you could use. So then after that, after all of the defines, we start to get into some live loops. And so the first live loops that we have, even before we get into the controller, are a CC tuner and a CC control. The CC tuner is something that I previously used to, figure out what the actual, not to figure out, sorry, but to set the specific MIDI mapping inside of my DAW. But I have since stopped using this because I find it really difficult and frustrating to use this sort of tuner function inside of the code itself, because then you have to go through and stop all of the other sections. So instead what I've done is create a separate document called MIDI control, where I have a function that just does 1 times do this thing, and then I set a specific MIDI value, and it makes it really easy to set MIDI values in whatever DAW you're using, because it just triggers it once, and it's not going to interfere with the playing of the other track. So that's the CC tuner. I could even remove this, but let's keep it in for now. Then we have the CC control, and so there are specific CC values that are going to be changing throughout the track. that are not linked to a specific phrase, right? So these are kind of like LFOs that are going up and down and up and down and up and down. And I want for the same like values to be flowing through for every single phrase. And so I kind of have them defined up top before we even get into the phrase controller. Um, the way that this is working is essentially saying we have a line and it's going to go up from 10. It'll take 40 steps to go from 10 to 30. So it'll go 10, 10.5, 11, 11.5, etc. until it goes to 30. Then, because there's this mirror, it's saying once you reach 30, go back down, right? And then finally, this dot look is referencing this tick so that every time this CC control live loop is called, which is once every beat, it ticks and it goes through kind of like in the same way that I described with the drums. So it'll start and say, okay, it's on this first one, it's at 10, then the second one comes in, it's at 10.5, and it's always looking at what this tick is saying. Cool. And then now, here we finally get into the sweetness, the reason why we're all here, right? The phrase controller. Let me actually stop playing for a second to explain this without the sound in the background. So, the phrase controller used to be just one live loop phrase controller that also had the live loops for each of the different instruments that are being called inside of it. But I found with the help of Pashultz that that was causing a few errors and just quite tricky. It wasn't acting in the way that we had expected. It was creating some unexpected behavior, and so they kind of helped me rewrite the function in a way that makes sure that things are a little bit cleaner. And so essentially, what the phrase controller um, is doing is first it's selecting what phrase is actually going to play, and then you'll determine how long that phrase will play before selecting the next phrase. And then finally, the phrase controller will set a global variable that all of these other phrases um, then get, and it is used to determine how the different instruments will act, right? And so I would say that altogether, all of these once put together is the phrase controller rather than just the live looper because it's kind of like this first function is setting the definition of what the phrase will actually be, which is then interpreted by all of these different sections that are making changes to the sound based off of what the phrase is based off of what the phrase controller is saying. And so I would actually say all of this, starting from here even, is the phrase controller. And so why I say that is because this value here, this first initial phrase, is kind of like what our initial phrase is going to be. So when we first hit run, whatever the value is here is going to be the first phrase that we have. And so this is very valuable for testing. But it's also very valuable for um, when you have your final composition setting what your initial phrase will be. If you wanted this to be something that is selected randomly so that somebody can jump into the track and it'll start from any of the phrases, you could do something like, 0 dash or comma 1 comma 2 dot choose, and then it'll randomly select between these values. But for me, with this particular track, um, I know that, the Cocteau Twin style stuff is going to be at -3, and the J Dilla style stuff is going to be at +3. And so I want it to start at 0 in between and then kind of let the program, programmatically decide if it wants to play more of the Cocteau Twin stuff before flowing back up and coming into the Dilla. And so for now, when I'm starting this, I started at 0. But just to kind of demonstrate the difference, or like how this works, I'm going to play it once in the middle, and then I'll play it again with -3 as the value. So when we hear it this time, it has the bass. Well, the in the code it's called bass, but here it's actually strings. And then we have the chorus, which is this first one. And the drums are playing in the background, but the CC values for these are making it so that we can't really hear it, right? But so let's stop it. That's kind of like the medium space. And then now let's play -3 and we'll hear some guitars much more frequently. So there we go. Immediately we hear the guitars coming in, and we've got these guitar values for both the guitars playing at the same time. And so I'll let this keep playing out as we go through this explanation. So looking at the phrase controller function, or phrase controller live loop, what's happening is we are setting two variables. The first variable is the phrase length, which determines how long the phrase will be playing for before selecting the next phrase. And then we have the phrase sequence array. And so this array is a number of nits back to back that are basically saying, if this particular value is chosen inside of the array, then you are going to choose between the different values that are inside of the nit, and they're going to be weighted differently. So for those of you who haven't seen the nit syntax before, just to quickly go through it, what's happening is when you put nit before inside of parentheses and then you follow it by choose, you will have two values for every potential randomly selected value that you're feeding it. So this first value is the value that will be output by the choose, and the second value is the weight of that decision versus the other options that are there. So here, the first option that could come out is -3, and it's 4 times more likely to be chosen than -2, which is only a value of 1, right? And so this means, to put this, in the context of this particular track, what this means is if my phrase is -3, I only want -3 and -2 to be the potential sequence or the potential phrase that is chosen next. And if it's -3, I want it to be significantly more likely for -3 to be the next phrase that's chosen. So then that can mean that, that section stretches out for a lot longer rather than just like jumping back and forth, going up and going down really quickly. But, the other thing that's really interesting about that is I could potentially make this a variable as well and say, maybe I want to programmatically control how likely it is to stay on a particular phrase. Maybe I want it to, sometimes be much more likely, or other times, be quite random or quite quickly moving through the different phrases. Okay. So from there, after these two variables are defined, phrase length and phrase sequence, we have the code that actually executes on these things. So in this line, phrase equals phrase sequence bracket phrase +3 bracket dot choose. What's happening here is we're saying the new phrase is going to be phrase sequence. It's going to be a value from inside of the phrase sequence array, and because we have the nits as the value, we don't want to put the dot choose inside of the array. Instead, we're going to have the dot choose come after this value is selected by the phrase sequence. The reason that we have phrase +3 is because phrase can be a value anywhere between -3 and 3. And so, but arrays, they only operate from 0 and up. So we're saying +3 because now it's saying, let's say phrase is -3, +3 will then tell it that it's actually 0. So it's grabbing the first value from inside of this array here. So you can imagine that this is now 0. And if this is 0, then it's giving you this nit as a value. And then it's now going to choose one of these, either -3 or -2, based off of this choose. Then what we're doing is saying set the global phrase to whatever phrase was. So then that way, all of the live loops that follow, like CC phrase, choir phrase, etc., have the same phrase value. And so this is really, really helpful because before, the phrase controller was a live loop with a bunch of nested live loops inside, which was just really, complicated and made it very hard to go through the code. Is causing different errors. And so this, by using the global phrase, the global variable of phrase, it makes it possible for us to set the phrase inside of this phrase controller and then pass that to the other live loops as necessary. And then finally, the phrase will sleep for phrase length, and as it was set at the top here. Cool. So then going in and looking at, let's start with the more complicated phrase, just to kind of explain the logic of it here. So inside of each of these different, actually let's start with something simpler first and then come back. So inside of each of these live loops, it operates using essentially the same logic. We have a series of if statements that are checking to see what the phrase is and then performing a particular action based off of what result we're given. So here in the drum phrase live loop, it's checking if the phrase is -3, then just sleep. Sleep for one note. That's all you got to do. Just sleep. But once we get down into, let's say, phrase 3, then it will it'll call the function of drum 5 followed by the function of drum 6, as long as the phrase is set to that, right? So it's calling this function that we've defined up here, and then it'll do everything that's inside of this code whenever phrase 3 is called. And so you can see here how this is operating to create that sort of dual track style that I was mentioning, where everything from 0 upward has the drums playing, which is creating that percussive sound or that percussive vibe, but everything from -1 down doesn't play the drums, and so it gives it that more kind of spacey ambient vibe, right? But to get a little bit more complicated, so this really shows off the idea here with the code. Let's look at the guitar phrase, right? And so under get phrase, we have for -3 through -1, these different guitar patterns will play, and they are being fed. We're calling the function get, and then we're giving it 4 different values that are then fed into the function that we defined up here to say, okay, the probability is the first variable, probability 2 is the second variable, probability 3 is the third, and then speed is the fourth. And so what we're seeing here is, coming down, the probability for the first one is 2, and the second one is 2, and the third one is 1. And so coming back, what it's saying is there's a 1 in 2 chance that this first instrument on channel 3 will play with a speed that is a combination or multiplication of sus, which is chosen at the very top, and the speed, which is coming from the function as it was defined inside of that other phrase live loop, right? Probability 2 is determining the frequency, or the probability of the second instrument playing on channel 4, And then for the third one, probability three, it's determining the likelihood of the two of them playing at the same pattern at the same time. Yes, and so that's like the more complicated of these of these Git phrases. And so I, oops, let me put that in there. And so this track isn't quite complete. I'm still gonna definitely keep working on it. Right now, the choir and the bass just kind of play, for the most part, the same thing. Or I mean, it's randomly generating, but there's not a whole lot of variation in there. So I'm gonna mess around with that a bit more. And then in here, we have some more CC phrases. And so with this, it's basically saying if the phrase is set to a particular value, then you should do a particular, you should alter one of the particular MIDI values using that sort of like LFO style that I mentioned before. And so this is very helpful to say, like, for example, I need to go in and change it so that the drum CC is makes it a lot easier to hear what's going on with the drums when it's in a higher phrase. Cool. And so I hope that this was helpful, at least on a conceptual level. I know it wasn't really much of a tutorial. This was definitely more of just kind of walking through some interesting code to give the idea of a particular concept, in this case, the phrase controller. And I hope it helped. Definitely let me know if you have any questions. In the description, I will post a link to the thread where I was talking about this on InThread, where you can ask questions there as well. I definitely recommend the InThread community. It's really, really helpful, especially the homie Pashultz, who really gave so many awesome suggestions for cleaning up this code. Great, thank you for watching. I'm going to let the track play out a little bit so that you can just hear it for a few minutes.